Hello, everybody. Miss Cyril here. So today we are going to have a review for the statistical treatment that we have last week. So let us start. Allow me to share my screen. So the statistical treatment is the process on which you are going to compute the data that you have gathered in your research. And we are going to review this one for you to have a reference in your analysis process. So let's have our objectives first. Our objectives is to define the meaning of statistical analysis and differentiate different statistical tools and to apply the correct statistical tools in your research. So let's move on to the world of statistics. So first we have the levels of measurement in here, which we have the nominal variables. So what are the nominal variables? These variables that are categorical and non-numeric or where the number have no sense of ordering. So this one is also called the named data. This one doesn't use any number but just solely the names. Next, we have the ordinal. So the ordinal deals also with categorical variables like nominal level, but in this level, ordering is important. So in ordinal, the natural order is valued. So numbers is being valued. Now we have the interval. One unit differs by a certain amount of degree from another unit. It does not possesses an absolute zero. So that means that it defines as a data type which is measured along a scale. It is also called the integer. Next, we have the ratio level. The existence of the 0 point is the only difference between ratio and the interval level of measurement. So in this one, it is just also almost similar with the interval one, but this one, its point of origin is starts at the 0 level. Okay, moving on. What is statistical analysis? Statistical analysis is the organization and the analysis of quantitative or qualitative data using statistical procedures, including both descriptive and inferential statistics. So we are going to have the two types of statistical analysis, which are the descriptive and inferential. So moving on, for more follow-ups, it's the science of collecting, exploring, and presenting large amount of data to discover underlying patterns and trends. So that is the statistical analysis. Now, as I have said earlier, we're going to encounter the two types of the statistical analysis, which is the descriptive and inferential. So we are going to start with the descriptive. What is the descriptive analysis? The descriptive analysis profiles question and those that involves mere counting and tabulations are examples of descriptive problems. So in this case, all the things or all the data that you are going to gather will be only under mere counting or being tabulated. Without further ado, let's meet the subtopics for the descriptive analysis. We have frequency distribution, we have proportion, we have percentage, we also have measure of central tendencies, MCT, we also have variability or dispersion. Now, we are going to have the first one, which is the frequency distribution. What is the frequency distribution? Frequency distribution is the data collected and often organized into formats that are interpreted easily. So we have an example here. There is a list of numbers which are we consider this one as our participants, our respondents. So these numbers are being counted. As you can see, they are being grouped. Class limits and then frequency. Here in the class limits, these numbers is tabulated from 13 to 15, from 16 to 18, from 19 to 21, from 22 to 24, 25 to 27. So you are going to count numbers from 13, 14, and 15. If you're going to count in here, then you are going to find 3 numbers. If you are going to look for 16, 17, 18, then you're going to have 11 numbers. If you are going to find 19, 20, and 21, then you're going to have 14 numbers. As well as 22, 23, 24, 25, 26, 27, and we have 5 and 7 for that. So in this part, this is the frequency of the numbers where they repeat or they comes back. That is why we put it in the frequency area, and it totals to 40. Also, our participants totals into 40. If you're going to count that one, our participants are equivalent to 40. Now, let's try and practice. We have a list of data in the right corner of in my right corner. Then we have this data of 4, 2, 3, 2, 1, 1, 4, 3, 3, 2, 2, 2, 2, 1, 3. We are going to try and tabulate our data. So as you can see, we have our demands and frequency. Now, the question is, how many participants do we have? Then you're just going to count the numbers. We have 1, we have 2, we have 3, and we have 4. So our participants are 1, 2, 3, and 4. So let's tabulate our participants. 1, 2, 3, and 4. Now, let's count how many times did the number repeat. Number 1, let's count. 1, 2, 3. So number 1 repeats 3 times. Number 2, we have 1, 2, 3, 4, 5, 6. So number 2 repeats 6 times. Now, let's have number 3. 1, 2, 3, 4. So number 3 repeats 4 times. The last but not the least, number 4. How many number 4s that we have? We have 1, 2. So our 4 has only 2 repeat numbers. Now, let us total our frequency. We have 3 plus 6 equals 9. 9 plus 4 equals 13. 13 plus 2 is 15. So we have 15 in all. So this is how you are going to do the frequency distribution. You're just going to distribute the data of the demands or the respondents, and then the frequency, how the data is being repeated. Moving on, we are going to have our next one will be proportion. What is proportion? Proportion is the total number of responses that falls into this category. It can be derived from the frequency distribution. So a while ago, this is also the data that we use in our frequency distribution. Same participants, same frequency. Now we have a formula for the proportion, which is P is equals to F over N. So our F here stands for the frequency, or P stands for the proportion, N stands for the total number of our frequency or participants. So I have mentioned a while ago that our participants are 40. Now let's try to plot if we are going to get our proportion. So our F is 40. And our participants a while ago in the table is also 40. Now our proportion is 40 divided by 40 is equals to 1. So our proportions equals to 1. Now, moving to the next one, we have our percentage. So what is percentage? Percentage simply means per 100. So it is the proportion expressed in percentage. So same to the two data that we have ago, we have the same example. And then we have a different formula. We have the percentage, the sign of percentage. And then we still have the F, which is the frequency, and N for our number of cases or our participants. So a while ago, we have 40 as our frequency and 40 for our participants. If you are going to divide that, then we're going to have 1. 1 times 100, then we're going to have 100%. So that is how we get our percentage. Okay. The next one will be the measure of central tendency, or MCT. We have 3 of them. We have mean, median, and mode. So what do you mean by the mean? Well, mean is the average value. How do you find the mean? To find the mean, you have to do first is to add all the numbers, add up all the numbers. Then you have to divide the sum by the number of the value. So we have an example. Our example is 3, 2, 10, 5. If you're going to add that one, we have 3 plus 2 plus 10 plus 5 will be equals to 20. How many of them? 1, 2, 3, 4. So there are 4. So 20 divided by 4 will be 5. So your mean will be 5. Next, we have the median. What is the median? So the median is the middle number. And how do you find the median? It's easy. First, put the numbers from the smallest to largest. The numbers in the middle is the median. If there are two middle numbers, add them and divide it by 2. So let's use the same example. So we have 2, we have 3, we have 5, and we have 10. Then our middle numbers are 3 and 5. Let's add them. 3 plus 5 will be equals to 8. Now let's divide the 8 by 2. And we will be having 4. So now our median is 4. Next, we have mode. So what is mode? Mode is the most frequent number. So how do you get the mode? Here, there are cases when how to get the mode. So special cases, we have no modes if all the numbers occur the same amount of times. So there will be no mode if there will be no number that would repeat twice, thrice, or more. Then there will be more than one mode if more than one number is the most frequent. So your mode will be 2, 3, 4 if it will repeat. If there are numbers that will repeat, you can have 2 modes, you can have 3 modes, as long as it repeats. Okay, let's have an example below. Let's try to get our mean first. So we are going to add. So 3 plus 10 is 13, plus 2 will be 15, plus 8 will be 23, plus 7 will be 30, plus 5 will be 35, plus 5 would be 37, plus 2 rather. Then plus 5 will be 42, plus 5 would be, 2 rather, plus 2 would be, where did I go? Okay, 3 plus 10 equals 13, 15, 23, 30, 35, 37, 42, 44. 44 will be divided into 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Oh. Okay. Let's add numbers. 3 plus 10 plus 2 plus 8 plus 7 plus 5 plus 2 plus 5 plus 2, and we will be having 44. 44 will be divided by 9, and we will have 4.89. So this will be our mean. How about our median? So we are going to arrange them from ascending order. So we have 2, 2, 2, 3, 5, 7, 8, and 10. Oh, we have another 5. So we have another 5. Have 7, 8, and 10. So as we have here, we have 9 numbers. Then our middle numbers will be 5. So our median is 5. How about our mode? Let's see what numbers repeats more than once. So we have 1, we have number 2, we have 2 here, 2, 2, and then we also have 5. So our mode will be 2 and 5. So that will be for our measure of central tendencies, MCT. Let's have the last one for the descriptive analysis, and we have variability or dispersion. So dispersion means the distance between your two numbers. Like this one, the range and the other more. We have the range, we have the average deviation, variance, and the standard deviation, which we're going to have later on. So let's start with the range. Range is the difference between the greatest and the smallest value. Like here in our example, we have the data 3, 4, 5, 5, 5, 6, 6, 7, 8, 8, 9. So our greatest value or the highest value that we have in this data is 9 here. And the smallest value that we have is 3. Then if we're going to get the difference, 9 minus 3 will be 6. So our range is 6 here. And the next example of the graph, our graph here, the fish hits 100. So our highest value is 100. And our smallest value is the reptiles, which is 20. Then if you're going to get the difference, then we're going to have 100 minus 20, and we will be having 80 as our range. So let's try in our data. We have the data 3, 10, 2, 8, 7, 5, 2, 5, 2. The example that we have in the MCT a while ago, then our largest value in here is, as you can see, it is number 10. So 10 minus the smallest value, we have 2. So 10 minus 2 will be 8. Our range is 8. Okay, next. So this is the one that I have told you a while ago. It is the average deviation. So what is the average deviation? Average deviation refers to the average of the absolute deviation of the score around the mean. So look at this symbol. Remember this symbol. This is the symbol of sigma for summation. Here we have our average deviation formula, which is the summation of x minus the mean over n. So we have an example in here. We have data 0.4 plus 1.4 plus 1.6 plus 0.6 plus 0.4 will be divided by 5. And we have 4.4 divided by 5 will be 0.88, and that will be our average deviation. Let's try to get our average deviation too. So our data is this one. This x bar is also means mean. This is the mean x bar. This is the absolute x, your absolute data. And then if you're going to ask where did this negative 14 came from, then add this one and it will came out negative 14 as your mean. Remember, how to get the mean is to add everything and then divide on how many participants that we have. So let's try to get our average deviation. So we have negative 10 plus negative 6 plus negative 3 plus 3 plus 6 plus 10 plus 18. But if you are going to observe, negative 10 plus positive 10 will be 0. Negative 6 plus positive 6 will be also 0. If you add negative 3 plus positive 3, then you also have 0. So the one that left is 18. Well, that is not our average deviation yet. We still have the formula. 18. This will be our total. Let's move on the top. So this will be 18 in here. And will be divided by 1, 2, 3, 4, 5, 6, 7. So there are 7. As you can see, there are 7. So 18 divide 7 will be, our average deviation is 2.57. So that will be our average deviation. Next, we have our variance. So remember, this is the symbol of variance, x squared. And then we have our formula. So again, this is the sigma for summation here. And this is our absolute value minus our mean, x bar, and it will be squared. So sigma x minus mean squared over n minus 1. So n is the number of sample size or our participants. So let's try to solve. So this data is the one that we're going to solve. So this is our mean. If you're going to square it, negative 10 squared will be 100. Negative 6 squared will be 36. Negative 3 squared will be 9. 3 squared, 9. 6 squared, 36. 10 squared, 100. 18 squared, 324. So let's get the total. 100 plus 36 plus 9 plus 9 plus 36 plus 100 plus 324, and we will be having a total of 614. Our n here will be 7 minus 1. So 7 because there are 7 of them. Minus 1, so it will be 614 over 6. So we will divide it into 6 and we will be having 102.33. So this will be our variance. The 100, again, let's rewrite here. 2.33. This is our variance. Okay, done to the variance. And let's have the standard deviation. This is the last one for our descriptive analysis. So here, what is standard deviation? Standard deviation, it is the square root of the quotient of the squared deviation of the mean divided by the total of cases. So a while ago, we have this one here. First, look at this. This is the sign of the standard deviation. Let me annotate. So this is the sign of the standard deviation rather. So again, summation of x minus the mean squared. So our answer a while ago is 102.33. And we are going to get the square root. The square root will be 10.1. So our square root is 10.1, and this is our standard deviation, just the square root of the variance that we have a while ago. So I hope everything is clear to you from the first one that we have our level of measurement. We have our statistical analysis, and the two types, we have the descriptive. Then we have its type, frequency distribution, proportion, percentage, measure of central tendencies, MCT, and then variability or dispersion. And the part 2 will be the inferential, which is the parametric one. So see you in the second video for the inferential one. So I hope that you learn, and goodbye for now. See you for the next one.